All right, folks, we talked about significant digits. Now we're going to discuss how we use sig figs when we are doing calculations. Okay? A calculated answer cannot be more precise than the measuring tool. A calculated answer must match the least precise measurement. Significant figures are needed for final answers when we're doing this. So, we have rules with addition and subtraction. We have rules with multiplication, division, and they're different. So we treat addition and subtraction one way, we treat multiplication and division in another way. And the biggest problem that I see, folks, is people mixing them up. People mixing them up. They want to use the multiplication and division rules for everything, which we can't do. All right, which we can't do. So we have special rules for each type of math that we are doing. Now, when we're dealing with addition and subtraction, the answer has the same number of decimal places as the measurement with the fewest decimal places. So what I will do on these, when I'm doing them, I take the last digit and I underline it. And I look which one is the furthest in that direction. Well, in this case, I see a tenth, I see 100th, right? So the furthest this way, the furthest left is the tenth, right? So I am going to round that to that figure right there. That's why I get 26.5, because the 4 does not round that up. Now, the only thing on this is it says the decimal place. The decimal place. Well, what if I had something like this? There's my answer, right? There's my answer. Do I have any decimal places? No. But the same rule is in effect. The same rule is in effect. What I do is I say, okay, here and here, so I'm going to use it as the ones place. I'm going to round to the ones place. Now, that's addition. You know, let's say that I've got the same numbers and I'm dealing with subtraction. $24.86 I get, right? If I'm doing my math right. Once again, I do the same thing. I just added that 0 in there, so I pretend like that 0's not even there, because I just added that. So my values are still at the same places as they were over here, right? But I have to round this now to that number, so my correct answer is going to be 24.9 for that one, because that 6 would round that value up. So whether I'm doing addition and subtraction, I need to check out the places. I need to check out the places. And to me, addition and subtraction is the harder one of the two. It's the harder one of the two. Let's do a learning check here. Go ahead and do your calculations for letter A and let's see what we come up with. Now, for this first one, I guess just knowing what I know about significant figures, I wouldn't even needed to calculate that, just assuming that whoever set up the question did the right math. Okay? I look and I say, okay, once again, I do my underlining. Here's a tenth, here's a tenth, here's a hundredth. So I am going to find the one, I'm going to round it to the tenth. This is the only one rounded to the tenth. So I'm saying right now that 256.8 is the correct value. Now, this gives me something that I need to talk about, okay? Something that we need to talk about. The number value that I got was 200. Let me do it in black so green doesn't show up very good. 256.75 is the number I got. Now, there is something that we call the even rule. Okay? Something in math that we call the even rule. And the even rule comes into play when I have the rounding digit being a 5. Now, if there is nothing behind the 5, all right, there's nothing behind the 5, that tells me that I have to make this value even. So I would round that 7 up to an 8. Now, based on the even rule, what would I do if this number was 0.65? I'm rounding that 5. I come here. Typically, you folks would round that up because it's 5 or above, right? We don't do so in science. Okay? We don't do so in science because of the even rule. So, is that number right there even? Yes. So we would round this into 256.6. Now, if you want to, let me take a short, let me get out of here and show you something. Let me show you something here real quick. Come back here. Let me go. Oh, where's my web page? Here. Right here. What I want you to do is get on this web page here. Go to Measurements and Calculations, which is, this is my web page. If you look at Measurements and Calculations, right here is the even rule. Click onto that, and I want you to read over this even rule. It's just, a couple pages. Read over that, and right here is examples of the even rule and how to do that. Okay? So that's one thing I would like you to do, and I didn't even write that down in your notes. Okay? Read over the even rule tonight. And if you want to, take some notes into your notebook about the even rule. Or if you want to just print it out and put it into your notebooks, that would be great too. Okay? That would be great too. So we've got this. What about the second one? What about letter B? What do you think about letter B? 58.925 minus 18.2. Once again, just saying that they did the correct math. Here I have a tenth. Here I have a thousandth. So I'm going to round it to the tenth because it's the furthest back. So my correct answer is going to be 40.7. Multiplication, multiplying and dividing. We round or add zeros to the calculated answer until you have the same number of significant figures as the measurement with the fewest significant figures. As the measurement with the fewest number of significant figures. Now, I think, folks, that this is the easier one, because we're going to do a couple here. We'll just jump right into it, okay? Here are 3 different problems. I look and I say, okay, right here, how many significant figures are there in that number? There are 3. How many are there in that number? 2. Which one, 3 or 2, is lower? 2. So I'm going to have 2 sig figs. So right there's my answer. I didn't even have to do the math. Once again, I'm saying I hope that they did the math correctly. Just a humorous. I'm going to see. The even rule only goes with 5. Okay? Only goes with a 5. So when I get my calculation, I have 9.198. Okay? When I round that to 2 sig figs, okay, I get right here is where I'm going to round it. At 9, we'll take that 1 up. Now, once again, I'm dividing here, but does it matter? Not really. How many sig figs right here? 4. How many right here? 1. Remember, those are leading zeros, so they don't count as significant figures. So, I'm going to have my sig figs is 1 sig fig, and that's the only one that has 1 sig fig, so that's got to be the right answer. 4.311 divided by 0.007, or not 0.007, 0.07, and I get 61.58571.429. All right. So when I look at that, I am rounding to 2 sig figs. So that rounded it to 60 instead of 61. My number, once again, just to show you, 61.6.15. Nah, 61. 61.58557. There's more numbers behind that. Once again, I am rounding it to 2 sig figs. So that's the number, or excuse me, to 1 sig fig, isn't it? To 1 sig fig. So I'm rounding it, whoa, right there. Okay, does that 1 round that 6 up? No. So it's 60. Remember that 0 is just a placeholder. What if I would have done this? That would make it wrong, wouldn't it? Because that would have 2 sig figs. Okay? That would make it wrong, so that would have 2 sig figs. And at times, folks, on scores, you'll see me write -1 SF. That doesn't look like an F, but it is an F. Okay? -1 SF, that means that you're missing 1 point because you have a bad significant figure. Okay, let's check out the bottom one. Let's check out the bottom one of our check. It has a couple of different numbers, has a lot of stuff going on, but I look and I say, okay, 3, 2, 2, 3. What's my lowest number? 2. Now with this one, I'm going to have to do my math because I have 2 of them down there that have 2 different ones. When I did my math, I come up with an answer of 11.288 repeating. Okay, I'm not going to put that on there because that looks like a bar for sig figs. 28888. Now I said that I needed two significant figures. 1, 2. Okay, that's going to, that 2 will not change that 1. So, right there, 11 would be my correct answer based on significant digits. Now let me check here if this is today's notes or tomorrow's. Okay, this is today's yet. This is today's yet. So, what we got here is reading a meter stick. Okay, this could be a ruler. Okay, but when we've already discussed this, but we're just going to reiterate to show you the significant figures. Okay, I look and I say, okay, on this right here, my measurement's right there. It is between 2 and between 3. So I know this is greater than 2, but less than 3. I've got between 2 and 3, I've got 10 little markings. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so each one is, excuse me, each one is a 0.1, correct? So I know that I have 10 point, as I'm looking at this straight on, I know it's 10.6, 10.7. I know it's 10.7. Is it 10.8? No, it's not at 10.8 yet, but it's 10.7. So it's in between the, or 2, I'm sorry, I was saying 10. It's either in between the 2.7 and the 2.8. So I know I have 2.7. I don't know that I don't have 2.8 yet. So here's where my estimation comes into play. All right? I look up there and I say, okay, my estimated value is this appears to be in between, halfway in between, to me it appears to be halfway in between those two dots. So I'm going to estimate that as 2.75. Now, will we all estimate the same? Could Andrew say, I look at that and that looks to me like 2.74? Yeah, we're not always going to estimate the same. That's why it's an estimated value. So you could be close. You could be what I say ballpark, but not exact. The known digits, the 2 and the 7, are 100% certain. The third digit is the uncertain digit. So the 6 is an estimated digit, or in my case, I estimated it to be the 5. Okay? In the reported length, all 3 digits are significant, including the estimated one. So when I'm reading that, how many significant figures would I have? 3 sig figs right here. Let's do a learning check right now in your notes. I want you to jot down what you would have for the answer of reading this line. Which one did you pick? What one did you pick? 1? I hope you did not pick 1, because 1 does not have an estimated value, does it? I know that this is 9. I know that this is 9.6. There's no estimation there. Could you have picked 2? Could you have picked 3? Yeah. Either one of those, 2 or 3, would be acceptable for this. Okay? 1 would not be acceptable. 2 and 3 would be okay. Now, let's look at this next one. Another one is 0 as the measured number. I'm looking at this, and I am saying that yes, first digit I know is 5. Second digit is 0 because it's not 5.1 yet, is it? And I'm reading this as directly on that line. So my estimation is going to be right here. So I'm going to say that that is 5.00. Here is a value of a graduated cylinder. Once again, I'm looking at this. I find my meniscus, which is the lowest part. I find my meniscus, and I look and I say, okay, I know I've got 50. What are my increments in between? They're ones, aren't they? So I know I've got 50. I got 51. I've got 52. I don't quite have 53, do I? So would this be correct to write 52.9? Yeah. Okay, yeah. What about down here? Here I've got 10. Here I've got 15, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to guess there's 10 in there. Okay? There's 10 readings in between 10 and 15. So each reading is 0.5, right? So here's 10. 10.5, 11. 11.5. Do I have exactly 11.5? That appears to me like it's right on that line, isn't it? So I would say right on that line is a 0. I would put 11.50. All right? Now that's tomorrow. So